Bacho Cave was first excavated in the 1930s by Dorothy Garrow, with subsequent excavations revealing a deep sequence spanning the change from Middle to Upper Paleolithic. Levels containing the initial Upper Paleolithic technology and large faunal assemblages make the site critical for debates about timing and adaptations of early groups of Homo sapiens in Europe. Bacho Cave is located east of Sofia, situated on the northern slope of the Balkan mountain range, and about 70 kilometers south of the river Danube. As you can see from this modern-day photo, the site is situated within a mountainous environment and is part of a larger karstic system. New excavations have focused on the main sector and niche 1, uncovering a deep stratigraphy spanning the Middle to Upper Paleolithic. Radiocarbon dating illustrates that layer I and upper J is between 43 to 46,000 BP, while lower J and K is between 46,000 BP and greater than 51,000. Blade technology in layers I and J is consistent with the initial Upper Paleolithic. Layer K is Middle Paleolithic. Layers I and J include personal ornaments, bone tools, and modern human fossils. Large faunal assemblages from K to I allow for detailed assessments of subsistence, behaviour, and change from the Middle to Upper Paleolithic. Detailed analyses of layers I to K collected a range of morphometric and taphonomic attributes, including weathering, bone surface readability, burning, and the presence of bone surface modifications from carnivores and humans. This first in-depth taphonomic analysis at the site aims to clarify human subsistence behaviour and change spanning the Middle to Upper Paleolithic. Since 2015, almost 16,500 individually piece-plotted remains have been recovered from layers I, J, and K. As you can see, most of this material is recovered from the niche and from layer I, with smaller amounts recovered from layers J and K and also from the main sector. Almost 7,500 remains have been recorded to date. 5,600 of these are from layer I. As you can see from this graph, the majority of remains from layer I, J, and K are below 50 millimeters, indicating a high degree of fragmentation. Despite this, we have a high identification rate, between 23 to 33%. Despite this fragmentation, we've identified a mix of cold and warm adapted species characteristic of MIS3 in the region. These include cave bear, boss bison, and red deer. Cold adapted species such as reindeer and wolverine highlight periods of extreme cold within these deposits. We've also identified some unique species, such as the golden eagle. We've highlighted some differences in body part profiles for major species of boss bison and cave bear from layer I. For boss bison, we can see limited head and vertebrate remains and a high proportion of limb bones, perhaps illustrating differential transport or selection of material away from the site. In contrast, cave bear illustrates a wider range of elements, including skull, vertebra, but also long bones and feet. This suggests perhaps that some of these individuals were natural deaths within the cave itself, while others may have been deliberately targeted, perhaps by human groups or other carnivores that occupied the cave. Bone preservation is amazing. We have excellent preservation in all levels, with over 90% of remains having most of their surface preserved, as we can see in these graphs here, greater than 50% readability. Similarly, most of the specimens are lightly weathered, being in category 0 or 1, and this is the same across I, J, and K. Natural modifications are limited. Greater than 95% of all specimens studied have limited abrasion. Similarly, we see in all levels, 98% of specimens have no root etching. This pattern you can see is the same across layers I, J, and K, illustrating excellent preservation of the surfaces. Carnivore modifications decrease from K into I. Human modifications increase from K into I. A chi-square test illustrates that this change is statistically significant and driven by the overall decrease we see in carnivore modifications across the sequence and the relative increase in human modifications within layer I. Carnivore modifications are recorded across a range of species including hyena, wolf, red deer, and wild aurochs, and smaller species such as hares. We have higher proportions of carnivore digested remains at 11% within layer K, decreasing up the sequence to less than 1% in layer I. This slide shows some examples of carnivore modification. On this long bone, we see these cut marks here, indicating disarticulation by humans, though around the edge here we have carnivore gnawing and a tooth pit. These two specimens here show a nice tooth pit whilst this specimen, also from layer I, illustrates quite intensive gastric etching. Human modifications are recorded in all levels, though predominate within layer I. We find most human modifications on herbivores, including caprines, boss bison, cervids, and even carnivores, including bear, wolf, lion, even finding one on a golden eagle. All parts of the butchery sequence are recorded. Here are some examples of cut marks from layer I: disarticulation on this rib, here similar disarticulation marks on this metapodial, and here on this cave bear phalanx. We have skinning marks here, more disarticulation marks here, and here we can see the golden eagle talon with a cut mark positioned here. These results from a taphonomic analysis of fauna from Bacho cave highlights that layer K has limited human input with a predominance of large carnivores. In layer J, we see a change in site use with an increase in human input. Layer I is a clear human accumulation with a range of animal species, variation in body part profiles, and a high intensity of bone surface modifications. Future work will look at differences between the middle and initial upper Paleolithic levels in terms of body part profiles, whether this varies by bone density or skeletal part indexes, looking at the age and seasonality of occupation, how the bone tools and ornaments were produced, and also combining zooarchaeological data with biomolecular datasets from zooms and ancient DNA. I'd like to thank you all for tuning in to listen to this Bacho, and I'd especially like to thank the Max Planck Society for funding, the National Museum of Natural History, especially Professor Popov, who facilitated access to reference material and collections, and I'd like to thank everyone from the Bacho excavation and lab team, and Karen Rubens especially for her input and discussion.